find if sin hx plus y equals sin hx cos hy plus cos hx sin hy. We have the relation sin ix equals I times sin hx, from where we obtain sin hx equals 1 by I times sin ix. In this relation, if we replace x by x plus y, we obtain this relation. We have sin x plus y equals 1 by I times sin I x plus y. We can multiply I to inside the parenthesis, and thus we obtain ix plus iy. Also, we multiply this expression by I on numerator and denominator. Thus we obtain I divided by I square into sin ix plus iy. We can replace I square by negative 1, and negative 1 is taken to numerator. Thus we obtain negative I into sin ix plus iy. We can expand sin ix plus iy using the identity sin a plus b equals sin a cos b plus cos a sin b. Thus we have sin ix plus iy equals sin ix cos iy plus cos ix sin iy. Now we can multiply minus I to both the terms. When we group minus I with sin ix, we can replace it by sin hx. Similarly, when we group minus I with sin iy, we can replace it by sin hy. This is because we have sin hx equals sin ix by I from this relation. If we multiply I on numerator and denominator, we obtain I times sin ix divided by I square. I square is replaced by minus 1, and minus 1 is taken to the numerator. Thus we have the relation sin hx equals minus I times sin ix. So after grouping, we can replace minus I sin iy by sin hy and minus I sin ix by sin hx. Thus we obtain the final expression sin h of x plus y equals sin hx cos hy plus cos hx sin hy.